So I would request Dr. Winfried Dam to kindly introduce our esteemed speaker for the address.
Everyone, I hope everyone enjoyed to have lunch. And this is not a panel discussion coming up. This is more than that. And you will really enjoy Mrs. Professor Sahajwalla from Sydney. And I'm really sad that we don't have 4 hours time for her lectures coming up. She's just an amazing woman. Born and raised in Mumbai, and had to go abroad kind of to revolutionize building materials, as she did in Sydney. And nowadays, I can't read all of her achievements. She received in 2017 the Plus Alliance Prize for Research and Innovation and the prestigious Jubilee Professorship by the Indian Academy of Science. In 2016, she was named one of Australia's most innovative engineers. In 2015, she was listed as one of Australia's top 100 most influential engineers. And so on and so on. Why all this? Because she came up and said, well, for green buildings, we have to use the waste. And then we have to do something with the waste. And now she is telling us something about microfactories, because one of the things I'm always telling as well, energy efficiency can't imply that you are flying around building materials around the world or ship it about over thousands of kilometers. It should be produced locally, should be used locally, should be adapted to the local environment. And now I'm really looking forward to have you on stage. Please come and let us know what you're doing. Thank you so much for coming the long way.
Thank you very much for that very kind introduction. I'd like to first of all begin by thanking the CEO of the GRIHA Council, Mr. Sanjay Seth, for the invitation to come along today and to do this talk. It's indeed a privilege, and I'm really inspired and very impressed with all the fantastic work that GRIHA and everybody in India has been doing in this space. I wanted to really begin by telling you a little bit about, at UNSW, we of course are really always excited about the fact that science and engineering and technology can have such a profound impact on people's lives. So, if you actually start to think in this particular occasion, we're talking about, sustainable development goals and sustainable habitat, and of course, energy efficiency. So one of the critical points, as was mentioned, of course, by our esteemed chair, that we have to understand how energy, of course, may well. So if we're actually spending a lot of energy in transporting materials and in transporting products over long distances, then that's one way, of course, we are, in a way, not quite gaining the efficiencies compared to being able to manufacture products locally and compared to, of course, being able to use the products that are manufactured locally. And that's really one of our motivations to develop this concept of microfactories, where we believe that it should be possible to be able to get the best outcomes for energy efficiency, that you should be able to take locally available materials and, of course, resources that are available locally in every part of the world are waste resources. So whether we're talking about combination of broken bits of waste glass, broken furniture, you can have waste textiles, and all of these types of materials that might come from construction, demolition, industrial waste, consumer waste, they definitely have got one thing in common. And the thing that is in common is all of us. If you just look around what we all generate in our own homes, we actually generate all of these different types of materials. So if we already have a system, which is a beautiful system that's already in place in India, where of course local collection systems exist through informal sectors where waste is collected, and it is in fact, seen as a really useful commodity. But of course, the challenge is, how do you convert that into a value-added product? So if you come back to the goal here today in understanding sustainability, it's not just about understanding how we might be able to reduce cost of transportation or bringing in goods over long distances, but it's also important to understand, could we potentially see technologies like here we're talking about microfactories developed at UNSW, which could actually produce value-added products that are fit for purpose? And that's really the key question. It's not just about recycling waste materials and doing it because you want to do the right thing for the environment. Of course, that's got to be at the core of the motivation. Why do we recycle? Because we want to be efficient when it comes to our resources. But the only way we can actually ultimately deliver long-term sustainability with these types of solutions is if these products are also functional products and they're also economically viable. To be able to have products that are then manufactured, that perform well, is important. So you can't afford to compromise on performance of these types of products. So if someone wants to be able to utilize products, for example, in building applications, so whether they are, let's take, for example, panels, flat products that go into, whether they are on walling or flooring, or indeed in terms of what goes into our kitchens, well, how do you actually make sure that you can in fact manufacture these types of products that actually perform well? And the fact that they come from predominantly waste materials should just be a nice little bonus. So it's not about saying we're going to compromise on the quality of the product just because it's come from waste. And this is where, of course, the science and engineering of how you actually achieve these outcomes is so important. How do you actually use science and fundamentally the material science to help you manufacture and create these types of products in a way that they're fit for a given purpose? Do you have products that are going to be strong? For instance, are they structural products? Are they products that are good when it comes to their acoustic properties? All of these questions, of course, are important. So if you can indeed customize the products to meet the requirements of a given end application, and if you could actually do that in a way that can be done from locally available resources, and of course, if you can do that in a way that you are using local people who are already in the business of collecting waste, you've essentially solved not just your environmental problem, but you've also in a way solved both social as well as economical problems, because you haven't just sort of seen waste as a burden, but you've rather seen waste as a brand new opportunity. So it's about creating new opportunities, and the social side of it is another fantastic outcome, because people who are working in these waste collection sectors, particularly the informal sectors, now you can imagine if we set up microfactories and if they were to manufacture products that people were willing to pay money for and install in their homes, you'd actually be creating local jobs. And you'd actually be creating jobs in many, many communities where otherwise those opportunities simply do not exist. So I want to put up an example before I get into some of the formal slides. And of course, I'll have these samples up for you. I thought the best way to actually prove the point that it can be done is by actually showing you a real-world sample. And this is exactly what we're doing at UNSW in our own microfactories. I don't know how clear it is from out there to the audience, but what this is a product that's made predominantly out of waste glass. So there's more than 80% waste glass in these products. Some of the other products that we have here, these types of materials contain waste textiles. So you can imagine all of these different types of panels that we're talking about in applications from a housing perspective are utilizing predominantly waste resources. And these types of waste resources are really what we're trying to do at UNSW in our microfactories, is deliver on these types of outcomes where, of course, we transform waste into value-added materials and products. So the Smart Center at UNSW not only looks at recycling, I've mentioned a little bit of what we do, what types of materials, but also on the other end of the spectrum is very much about manufacturing. So our solutions in terms of green manufacturing are developed through partnerships where we're working with social enterprises, we're working with businesses that actually are interested in waste recycling. So no longer we just see waste recycling as just an entity out there doing something because it's good for the environment. But if we can couple the two, recycling with manufacturing, then of course we've created a whole new shift in our paradigm in how we can enable waste recyclers to actually become manufacturers. And I think that to us is quite an exciting journey in terms of how we can take some of these new ideas. And the translation ultimately has to begin with fundamentals of materials science. Ultimately, of course, when you develop new green solutions and new products, you have to be able to trial and test them. And the test bed at UNSW, the microfactory test bed, allows us to do that, allows us to take different types of solutions and look at the possibilities of commercialization. So when I say we're partnering with different types of industries, I thought I'd give you a little bit of a overview. And of course, what this slide really shows you is in the middle, in the pink color, it's very much about all the different types of input waste streams, like I was referring to earlier. Our glasses, our waste coming from food packaging, for instance, lots of waste plastics available to us. And of course, at the high-tech end, we've got waste electronics and batteries. So you can imagine in all of these areas, we've actually got tremendous resource. But that resource, unless and until we transform them into value, will not deliver on its potential. So that's really the key thing. How do you actually transform them into value so that we can actually create those types of industrial solutions? And microfactories is one pathway in which we can do that. So on the outer green circles that you see there are precisely the examples of the kinds of products that we're making. Some products are meant for, of course, industrial applications, like the high-value carbon products. Some products, they start with industrial applications, but they end up producing consumer goods. So for instance, we've taken plastics from e-waste, electronic waste from our printers. We've converted them into smart filaments. These plastic filaments are made out of 100% plastics, and they're then used for manufacturing consumer products like spectacle frames. So all of these are examples on how we can actually take something that is of relatively low value and create products that people need. There's a win-win outcome in there. The win-win outcome is that the consumers can actually now get products that are far more affordable. And that's the key here, that ultimately it's the consumer, it's the people who win if we can really deliver these types of microfactories and solutions. So what you see here is an example, of course. I just wanted to give you a bit of sense of what are the challenges when it comes to waste that we're facing. And you might say, well, what's that got to do with building industries and energy efficiencies and so on? Remember, in all kinds of applications now, in the building sector, there are all kinds of electronics that are embedded in different applications. So how do you put in sensors, for example, into building applications? How do you actually make sensors that are affordable? How do you do it from locally available materials? And this is where, of course, the transformation that microfactories brings is about producing industrial materials, and that's exactly what we're doing. And so I wanted to put up this slide here that actually shows you, and you can see very much around where India sits in the scheme of things with e-waste that is generated by different countries. And of course, you do have tremendous potential in India, as you do in so many other parts of the world. The ability to take, for example, this e-waste. And of course, when I say e-waste, remember, it is a complex mixture. Your normal desktop printers and the photocopying machines are plastics hardware. You've got circuit boards that have got a lot of metal on it. So you've got different types of materials in there. So the opportunities are significant. What are these opportunities? Of course, there's basically a whole range of studies that have been conducted to show that there are indeed billions of dollars worth of resources that are embedded in there. That means that can be translated into real-world jobs and ultimately, of course, real-world products. So without sort of, spending too much time and explaining this in great detail, I just wanted to be able to give you a little bit of an overview as to waste products, how complex they can be. So on one hand, you can have something as simple as glass and plastics. On the other hand, you can have something as complex as a printed circuit board, which has so many different types of materials on it. You, of course, have got therefore, an opportunity with microfactories is to start to convert those waste into resources. And that's really what we are all about, is creating an opportunity so that they can be put into various applications. So here's a picture of our microfactory at UNSW. We've launched this microfactory this year. And next year, the green microfactory that we will be launching will actually be generating products in commercial scale machines at UNSW. So all of this is really just to be able to make one very simple point, that the vision that we want to talk about is a vision that benefits ultimately everyone on this planet, whether it's Australia or India, it doesn't matter. The one thing we all have in common is that we all generate waste materials as part of our everyday lives, as part of our industries. So we can actually imagine that people who are working in this sector, for the first time at a local level, at a micro-factory level, actually are empowered to create high-value products. And I think that's where the shift needs to happen. We can't afford to always see the traditional business models where you just have the mega sort of factories doing what they do. If we want everyone to be part of this new future, we need to be able to make sure that everyone's part of the supply chain. And so therefore, small or large producers can all work together. And this is where, of course, the vision of microfactories can bring this to life. So what this is really showing you is how we've taken waste plastics from our printers. We produced our filaments, the smart filaments that I was telling you about, 100% waste. All of this work is scientifically proven and published, so certainly there's a lot of research that's already out there in the public domain. But what this is showing you is that we wanted to be able to create plastic filaments that are good enough to be fed into your everyday average 3D printing machine. So that if you've got even a small, very basic 3D printer, which is really what you're seeing there on your right-hand side there, is a 3D printer that's taking our waste plastic filaments and using that as a feedstock to manufacture products. And there's where exciting new examples come in, that we're shifting manufacturing, where we're saying, if we've got access to these types of waste plastics, as long as we know what's in those waste plastics, as long as we understand the science, we can actually deliver on these types of localized manufacturing solutions. So let's look at what else is out there. Like I mentioned to you before, the full spectrum of opportunities exists. We've been doing a lot of work in textiles. I was showing you some of the panels with textiles. We've done a lot of work in using waste rubber tires as a feedstock for manufacturing steel. And of course, with e-waste, there's a whole lot of legacy waste. I mean, just the example of old TVs and computer monitors. You look at what we're using today as opposed to what were in our homes not that long ago. It's interesting to go back and contrast some of the legacy waste materials. And we've got to be mindful that in some instances, a lot of the waste, like for example, electronic waste, may well contain toxic elements like lead. So we can't just be complacent about it. We need to be very careful in terms of how we process these materials. Again, waste glass. So here's an example of a perfectly valuable material, waste glass. Windscreen glass coming from cars, of course, that can't be put back into application once again in the form of a car, but that glass at the fundamental level, those elements that are there in glass, the silicon and oxygen, all of those materials, all of those elements, they don't disappear. So just because at the macro level you see a broken piece of glass doesn't mean that the elements are no longer useful. And that's exactly what we are showing. We're showing that through transformations that we're carrying out. In this instance, you're seeing right in front of your eyes how a combination of waste glass and plastics actually is reacting at various high temperatures to generate products. In this case, we've taken circuit boards and converted them into valuable metallic alloys. Again, you can see the alloys on the right-hand side there. They can be alloys that are rich in copper and tin. So you've got a whole range of new opportunities to be able to transform these materials into useful alloys that are, of course, fit for industrial purposes. So even something as simple as copper, right? I mean, you might think, well, Why is that an issue? Well, it's an issue because, of course, you've got to ask, well, where is copper sourced from? Copper, of course, depends on our ability to go off and mine copper ore. The fact that you need copper for all kinds of electronic applications, including in our cars, in our buildings, in our communication systems, because copper is at the very backbone of delivering electronic connectivity. So that's very important that we recognize that all of these important elements that we may just have taken for granted are not going to be here forever unless and until we start to imagine how we can reform our waste products, complex products like our glasses, our circuit boards, and so on, to create these types of fabulous copper alloys. So this is where some of the new technologies at UNSW show that we can not only do the 3 Rs very productively, the reduce, reuse, recycle, but what we are talking about is that when you have got a complex product, you then have to stop and say, well, how do you actually create new solutions? Because it's not as easy as a simple plastic becoming another plastic filament and then becoming another plastic product, or a glass that's simply melted and creating new glass. What if you've got a complex mixture of different types of elements? How do you actually then do something meaningful with it? Again, not just recycling for the sake of recycling, but rather indeed creating alloys that have got a market value and have got a market potential. So whoever works in these microfactories is able to on-sell these types of valuable materials. So that empowerment at the local level is not just about recycling and creating jobs, but they're about creating jobs of value and jobs with a purpose. And I think, to me, that's really what we've got to start to think about. Not always think about economies of scale, but rather think about economies of purpose. The purpose here is to be able to reform the products that we have, the waste products that we have, and create new alloys. And this is where, of course, an example of why we need the 4th R. So going beyond the 3 Rs of reduce, reuse, recycle, we need the 4th R to help us take those complex mixtures and create new products for our society. And so coming to, of course, what we've done in the area of building applications, I just wanted to throw something up like this for you, because it again goes to show that we're sitting on enormous opportunity. We don't have to see waste, again, as just an environmental problem, but what we have to see is effectively our ability to create products that actually have further applications in our built environment. So all kinds of things that we you see here on the screen. So whether they're about glass-based products, the ones that I was showing you earlier, these types of glass products, of course, have got strength, and the reason why we create these types of products is they need to be strong for our everyday applications. We need to also look at the possibility of, in many dense places, acoustic paneling, for instance. But you want acoustic paneling that's not just going to be sound absorbing, but it's going to be strong. So how do you actually create acoustic panels that are going to have combination of the right acoustic properties as well as have strength? This is where you need to think about hybrid products. So you bring in, of course, not just waste textiles that I was talking about, but bring in waste wood products. So waste wood products, of course, typically come down to materials like our waste furniture. They can come down from waste agricultural resources. So you can see the particle boards that you see there are produced from all kinds of waste agricultural products. And of course, every part of the world has got its own unique feature. We've been able to show that it is possible to actually produce these types of sustainable particle boards out of using things like waste macadamia shells. We have gone to remote communities in Australia where we've taken the local materials that people are actually simply burning away and transforming them into some of these amazing products that can then go into our housing applications. Again, from a flooring perspective, we've taken different types of really complex plastics and converted them into products. So what do they really look like? I'll just probably, in the interest of time, take you through some of these very quickly. This is an example where we've incorporated a lot of marine waste, and we use them as biofillers into our hybrid biocomposite applications. And of course, they have strength. They can be utilized, for instance, for architectural applications, ceiling panels, structural panels. Here's an example of what these amazing, beautiful acoustic panels look like, made out of textiles. And indeed, this project started out with a simple motivation. We're partnering with a social enterprise, Resource Recovery Australia, where they were effectively collecting waste mattresses, and of course didn't know how to deal with disposal of these types of waste mattresses. So from that point of view, our ability to partner with social enterprises has been actually really, really remarkable, because we love the fact that, you know, we can have people from social enterprises just imagining different ways in which it can create valuable jobs in those local communities. So it's not just jobs in manufacturing and making, but think of it. Once you make a product, you've got to sell it. So it's also creating subsequent jobs in retail and marketing. So I think the ability to create all kinds of fabulous products that you see here. Here's another example of what I was showing you earlier of this stone products, where we can show that indeed a lot of these types have got fantastic properties that allow us to use them for different types of application inside our built environment. So indeed, of course, walling, floor tiles, and kitchens and so on, and bench tops, indeed, like I was showing you earlier. So here are some more examples of what these products look like. And of course, it really comes down to, so here's, I'll put this sample up again. There's a combination of wood and PP, polypropylene textiles, that we've chosen in this case. And then there are a whole range of different types of combinations, as we've shown here. It's not just about polypropylene, it's not just about polyester. But the reason why I'm putting up all of these examples is, again, when you think about something as basic as waste clothing, and you think about the sector that, in fact, you know, operates in different parts of the world. Different places have different ways in which old clothes can be collected. And of course, as a result of that, what you've got to imagine is if we already have systems where old clothes are being collected, yes, some of them are fit for reuse as clothes again, but some perhaps have reached the end of their lives. So does that mean that that fundamental fiber that exists in these old clothes is no longer useful? Not at all. In fact, those fundamental fibrous materials is exactly what we've taken, and we've shown that through our microfactory technology, we can create these types of panels. So the ability to take that complex mixture of different types of fibrous materials that are no longer fit for wear as garments can then, of course, be put back into applications for panels. And so there's a lot of work where we've done in terms of doing a lot of mechanical testing of these panels. Again, as I said, a fair bit of data that's already been published out in the public domain, so people can go and have a look in terms of what kind of requirements they have to meet, whether they're general purpose or load bearing or heavy duty applications. All of that information's there. Again, our work in terms of understanding their properties when it comes to sound absorption, all that information is there, so we can compare the acoustic properties as well. What else? Now, we've recently published some of this work where we've shown that for flooring purposes, we've actually used basically someone who approached us said a lot of advertising banners, for example. Once the advertising job is finished, there are lots of these banners that are available. Can we put that to good use? So there's a beautiful example where somebody approaches us, and of course, from our point of view, it's exciting to be able to go back and see the endless possibilities that that could exist. Here's another thing that we've done more recently, where we're looking at the whole sort of coffee industry, whether it's around the coffee cups or the residue waste coffee. The reason why I talk about waste coffee, remember I was talking about plant-based materials. And of course, in this instance, a lot of the waste coffee that's left behind, and of course, we're partnering there with Planet Ark in Australia. Lots of work happening now where there's awareness around this industry, this consumer industry that is producing a lot of waste resources. So I'll just skip through all of that. There's an example of a lot of agricultural waste for particle board applications. Lots of waste. I'm not sure if you guys can guess what that stockpile is, but tires, that's right, fantastic. A very scary pile of tires. I call it scary because you can just imagine if something like that ever caught fire, what a disaster that would be, right? So we need to be mindful of the fact that it's not just out of sight, out of mind. It can have huge impact, not to mention waste of a beautiful resource, energy, materials. And what we've done here is the example of what we've shown, that in steelmaking applications, we've reduced our consumption of coal, and we've actually replaced that with use of tires as a source of carbon, and as a source of not just replacing a carbon that traditionally coal has, but tires actually enable us to reduce carbon emissions by bringing in hydrogen. So the molecule that we introduce into the steelmaking furnace, by simply putting tires into the furnace and reacting it, as you see in that video in the middle, is about creating a whole new resource, a clean hydrogen gas that is available at a relatively low cost by simply that in situ transformation. So that's really the origins of our green steel technology. We've commercialized green steel in many parts of the world, including in Australia with our Australian partners, and of course with UNSW taking the charge and the leadership in this space. So really from our point of view, what I hope I have conveyed to you today is that the ability to look at waste not just as an environmental burden, but rather to see it coupled with manufacturing and putting that into practical applications can come to life on small scale. And that is an important understanding of where we would like to see the future, of course, evolve, because ultimately we need to be able to see everyone being empowered to be able to use local waste resources and to be part of a global supply chain, if indeed that's what is desirable. But on the other hand, more importantly, is about delivering locally made products, so that if you want to be able to fulfill our goals to deliver sustainability in a way that is affordable and doable on a local scale, then we need to think about how small-scale manufacturing can come to life on the back of waste resources. Thank you so much for having me here today. Thank you.
Thank you, Professor Sahajwalla, for sharing your wonderful work with us. I would now request Mr. Sanjay Seth, CEO, GRIHA Council, to felicitate Professor Sahajwalla.
Well, ladies and gentlemen, I had the good fortune of visiting her smart center and looking at the micro factories. It was overwhelming. I mean, the kind of work that she's doing. And basically, she's here today on my request. I had requested her that she should come down to India and speak about her work. Thank you very much. Thank you very much for coming.
These paintings showcase Gond art, which comes with the belief that good image brings good luck. The Gonds are major tribal communities of central India. The artists have used natural colors derived from charcoal, colored soil, plant sap, leaves, and cow dung. This mystical art form is created by putting together dots and lines. Thank you so much, ma'am. After this session, we have two thematic tracks. Track 19, Emerging Building Technologies, shall take place in this hall only. Track 20, Advancement in Building Optimization, is at the Friendship Lounge right across this hall. Thank you so much for hearing us.